Good morning. My name is Andy Lawrence, founder and CTO of the Digit Management System. It's a general purpose data management system that we're developing. We're an early startup, meaning we're just coming out of stealth mode. We've attracted some outside investment for some additional funding. We've got a couple committed customers lined up. We've got a number of others that are interested in our technology. They're giving a serious look. But we've been around a while. We've been doing this for about 5 years, kind of on part-time. My wife keeps telling me it's a hobby until we get the money coming in. And so, yeah, I'm here to tell you about my hobby. But it's a very ambitious project. We've had limited resources, and that's part of the reason why it's been as long as it has been in the development of this. Now, Digits is a new kind of general-purpose data manager. We create these data objects we call Digits, which is a short term for data widgets. It handles diverse sets of data, so structured data, things like normally goes in a database kind of model, but also a lot of unstructured stuff that is typical for file systems. My background is mainly in file systems, so I started this out as a simple file system replacement, not just another file system, but a file system built upon an entirely different kind of model. And I knew I wanted to build a lot of database kinds of capabilities into it, but those database capabilities end up working so well that I wanted to have multiple models. So I want to be able to put relational type data into this, graph databases, all the NoSQL kinds of structures out there. First of all, why build something like this? After all, we already have tons of data managers out there. We've got file systems, we've got relational databases, key value stores, document stores, all the NoSQL stuff. We've got distributed with the Hadoop file system and the distributed databases and all these kinds of big data kinds of architectures out there. And sometimes there's hundreds of implementations in any given category. I know there's been more than 100 file systems invented over the last 60 years. Some of them are very niche products that only apply to certain things, but yeah, we've had a ton of them. So the last thing I wanted to do was sort of build another sort of data silo where, oh, here's just one more thing. Yeah, it might cater to a very small subset of data. Maybe it's a file system that handles very tiny files or something like that. I didn't want to build that kind of thing. I wanted to build something that was very general use and would make some significant differences. So the purpose of why I wanted to build this thing is, once again, give users control of their data. Too many of these other data managers are basically a silo. Give us your data, we'll hide it all behind this nice walled garden, and to get your data out of it, to put it in a different system is very problematic. When it comes to one of the last companies I worked for, we had a product that was literally talking to 5 different databases. Mongo and Postgres, and so had a SQLite and a proprietary thing, and so they had to come up with interfaces to all 5 systems. When it came time to do things like replication or backup or security, they had to get all these things in sync to take a snapshot of their data. It was a big pain. So I wanted to be able to pull a lot of that stuff into a single system with a single model for security, for replication, backup, and things like that. And I wanted it to be very superior performance, meaning a lot of big data kinds of things are now being pushed down. I mean, I remember it was less than 20 years ago I saw an advertisement for the first terabyte system. It was $1 million, and it was like two refrigerator-sized racks there with 500 hard drives in them. And now you can go buy a terabyte hard drive for what, $40. And so a lot of those big data capabilities are now being pushed down to even small systems. And we want to have maximum flexibility, be able to create a variety of different kinds of data. Well, a lot of times, people work on a system and they come up with a new database or a new file system that's 10% faster or 5% faster over here, or does something very, very minor. But what I wanted to do is do something that was going to really up the speed. I put 2 times as my minimum, so it wasn't at least twice as fast as what I was used to. I didn't want to bother. I wanted to have broad capability, and scale from simple devices with small amount of data all the way up to these big clusters full of with petabytes of data. And of course, anytime you're innovating and you want to do something, you either got to do something that somebody already else does a lot better than they do, or you have to come up with something that nobody else is doing. So let me show you just a real quick demo of a couple of things that that this system can do. This is our administration tool that talks to our system. We call it our browser, but I've got two different containers on here in which I've stored a bunch of my objects. We have some different ways of putting objects in here. We can import files from a file system, and that's what I did for this second container. I took my C drive with Windows 10 just installed on it and imported them all as digits. Created 167,000 digits in this, basically equivalent of a file system. This other one, I created a bunch of test digits, and there's almost 28 million of them in here. So if I want to do a query and say, find me all my photos, that fast it'll find the 15,000, you can see down in the bottom right-hand corner, 15,000 different photos. If I want to see just the JPEGs, we see of those 16,000 photos, only 4,000 of them are JPEGs. Documents, every one of these queries I'm doing is hitting the metadata table with all 167,000 records in there and extracting out just the ones I'm looking for. Do the same thing on the 28 million one, and again, I'm looking at all 28 million records for documents and found 3.7 million of them were documents. So very, very fast, small metadata record. I can read it all in just a few seconds, keep it all in memory with a small amount of memory, and do queries against them. I can also, so our system also puts tags on things. So back to the query. So for example, let's grab a simple file that I imported here. We added a bunch of tags to that, took a SHA-1 of the data, attached that as a tag, the file name, paths, folders, and things, added them just as tags on these things. So we can do reverse lookups and go over to our tags and say, find me all the unique file names that we had. We deduped the data, reference count everything, so you can see here, so license.txt file, for example, was repeated 247 times in my hierarchy. And there they all are. If we wanted to see them all, we could just come over here and click on it, and there they all are. We could see each one, see the tags that are attached to them, and that kind of thing. So I wanted to build something that was very, very fast, very flexible, make it like a digital erector set where we have lists and bitmaps and markers and things, tags for key values and things like that. In our database world, we can create relational tables. Here's one with 1 million rows, 10 columns. Just imported standard CSV with a bunch of names and addresses and things like that. Do a select all, and we can create custom queries on there. Here's one with people with West addresses and .NET emails. In a couple seconds, it comes back with the 33,000 rows in our 2 million row table. So, done some benchmarking against like Postgres and MySQL, gotten some really favorable results here. So, don't have time to show you even a tenth of what this thing can do, but that kind of gives you in a nutshell a few of the things. Whoops, where's my? Did it close that? So sort of startup insights, as we kind of get this thing going, it just can be really hard to get people's attention. Started to approach people when we just had an idea, and they're like, we can't really see it. We need to see a demo of this kind of thing working and put some real data in this. And it wasn't really, that's why we're just coming out of this, is we finally got enough stuff working that we can go to our customers, put their real data in it, and they can say, wow, this thing really performs the way I need it to work. Second insight is, it's really hard to find people to sort of help you out with these things. It's kind of like the little red hen story, if you're familiar with that. This little red hen finds some grain and says, yeah, who will help me make some bread out of this grain? Tries to recruit their friends to help them plant the wheat and then harvest it and mill it into flour and bake the bread. Nobody wanted to do anything until the bread was done. And then everybody wanted some. we've taken this to a lot of people, and they'll say, yeah, that's a really good idea. Let me know when it's all done, and we can try it out. It's like, well, can you help us get it there? And it's really hard to get people to do that. And of course, any startup, trying to manage, how much you give up in equity in the company for real value. There's plenty of people that want to take a big piece of the pie for very little value. But want to make sure that if you're giving up half the pie, whatever you're giving it up for is going to double the size of the pie. Otherwise, you're behind. And then in picking, just pick the right team. Get people that have technical capabilities. Getting the connections. This is really what helped us with the investment is people with connections to these companies in different industries that can open up some doors for us. So that's kind of it in a nutshell. I'll turn it over to Manuel.
Thank you, Andy.
Hello, can you hear me well? Yes? Okay, great. So, thank you very much for giving me the opportunity to be here. It was really a pleasure. Last year, I first attended supercomputing and I couldn't attend this Startup HPC event. In fact, Rosal, one of the members of my team, talked me really good about it. So it's really a pleasure to be here, and thank you for the invitation. I have not prepared any slides because I'm really proud to say that after 4 years of work, I come from the university. I've been a researcher for more than 10, 15 years. I came up with research results that were published very well. But at some point I decided that I felt I wanted to do this, or convert it into a product that could be sold. And at some point I didn't know really how different this world is from research and academia. And now I'm figuring out after 4 years with the startup company. So it's a pleasure to say we're really proud. We have been selected for this emerging technology program in the showcase in the supercomputing. So I will not present any demo here, and would like to invite you all to see the demo of what we are doing, of our work, at room 155B in the exhibition hall. It's free access, so please come there. We can discuss and see the demos of the product, so you can really figure out and see and touch what we are doing. So here today, I have preferred to concentrate on our journey as a company and my personal journey as going from a researcher to an entrepreneur, CTO, and now CEO of the company. That is really a very biggest jump that is unexpected, going from research to create a company and creating a product that can be commercialized. So, to summarize, I have tried to figure out how to summarize 5 years of work or even more in just 5 minutes. So I have decided to use some of the recommendations that someone called Alex Vier, that is the CEO and founder of Red Herring. Red Herring is one company that gives awards to companies, startup companies that are doing really well, both in the US, in Europe, and across the world. And we were lucky to be one of the companies awarded in Red Herring Europe in April this year. So I had the opportunity to see a conference by him where he talked about 10 recommendations that every entrepreneur should follow. And as I am first-time entrepreneur, I would like to know who of you are first-time entrepreneurs, first-time CEOs. Okay, I have to say that he talked about 10 recommendations, and I have to say that we failed in the 10 of them. All of the things that he said, try not to make these failures. We did all of them. So I would like to summarize only some of them. He said, dream big and dream in colors. Persevere and never give up. Hire slow, fire fast. This means that as a CEO, you usually have a vision that no one else in the world can have, because they don't have the expertise or don't have the the knowledge to know exactly how you envision your product or what you can do with your technology. So somehow you have to persevere and never give up and never say you will receive very good opinions, very bad opinions, stop doing that, go on back to research. If you are really convinced that you are going the right way, keep on persevering and doing it. And one of the most difficult issues that we face in Apentra is finding the right team. It's something that someone talked about it this morning. And I have to say that we began with a team, and after 3 years working with them, we felt that something was not really going well, and we decided to keep on giving second and third opportunities to these people. And in the end, these people decided to leave the company, or we had to fire these people because they're not really convinced to follow our vision of what we are really doing. So hire slow and fire fast. Do not hesitate it. If you are not comfortable with your team, please do not hesitate. There is many more companies where they can work, they can find their way, but you need to find the people to do it your way and find your way. And you are the CEO, and they have to follow you, and they have to really believe in what you're doing. So that's one of the things that I would like to say here, because it's personal experience. The other one of the recommendations is sell, sell, and sell. But from my point of view as a startup, in a startup, we don't know what we are going to sell. We don't know what the product will look like. We don't know which product people will really buy. So how do you sell something that you even don't know how it will look like? So I think that sell for a startup company is most about talking about people. Engage with people. Find a way so that these people trust what you are doing, what you are saying, and trust you and your team. That's the way to build these connections and relationships from scratch. That's the way you have to do it, at least this is our experience. So that's the way I understand this sell, sell, sell. People, and people, get people to trust you. And the other thing is, startupping is really harder than expected. So the other recommendation I would like to finish with is manage your life, your health, and your balance. The day only has 24 hours, and you want to do things, and if you had 40 hours a day, you could be 40 hours a day working in your company for your startup. But you have to find the balance, because you have a family, you have children, you have friends, and you have to take care of all of them for you to feel good, for you to be really well while you're working with your team, so that they can really follow you, they can really trust you, and you can really feel well and transmit that to the people you are trying to engage with. So he talked about other recommendations, but I really believe that these are the ones I would like to highlight here, especially for, as me, first-time CEOs, because it's our first company, and you really fail where you really think you will not be doing those mistakes. You will do it. Don't worry about it. Do it, learn, and keep on persevering and doing it. That's the best thing I think I can say to summarize and to finish this very short 5-minute presentation.
Wow, thank you. That's great.
Today I will talk about Fly Elephant, about what is it, and about our history, how we grow, and what we do, and what helps us to growing. We create the platform for data scientists and help him to do their work more quickly, more easily, and help him to use high-performance computing in their work. For this, we provide for data scientists and engineers quick access to different computing resources, clouds or supercomputers and HPC clusters. We provide for them computing-ready infrastructure, which consists of software what they need and the power what they need. We built the collaboration platform which help him to work together, to share the result, to discuss about the project and so on. And we help him to deploy their services, their results, their computing tasks as API services. And we create the community near our platform which can help him to solve the hard problem when they cannot do it. First, we do all this for individual customers, but a little I say what was happening. Today, our community is more than 1,000 our users, and we start to build the partner community of big companies. Today, we have partnership with best bigger industrial company and with different R&D center of service companies from Ukraine. And what was our history? I started this project as my master work. Then I tried to test it on hackathon, and we take third place. And I understand that I need to try to build the company of this project. So in August 2014, I founded a company and we start work. We show our project on the biggest Ukraine startup conference, IDC. This conference was number 5 in Europe. And on this conference we take the best cloud startups, and it will be very good. Then we launch our platform in online, and it was a year ago when we come to first time come to supercomputing and come first time in Silicon Valley, where 1 month we work and try to understand how startup ecosystem work in the United States. On this year we have several releases, and in September we understand that we need to change our focus from B2C market to B2B market. Why? Because our users data scientists or engineers, but the money have companies. So we start very new hard work, how to sell and what we need to do for sell our product to companies. For now, we have one demo case of using our platform in production. I want that it will be finished good, but we do it for now. What helps us to do and growing? First of all, it's our connection. Second, very good helps us accelerator, which give to us new connection, and the 1 month's work in Silicon Valley. Also, very good help us advisor board, which do new connection too, and the several startup program in Microsoft and Azure, which give us free resource, and using this resource we can take the feedbacks of our system from our customers, and the partners give us the supercomputing resource, and we can work and test our system on the supercomputing. Also, very good work conference where we take new contact, but we not only participate in the conference, we organize conference too. So the community in Ukraine and Russia-speaking country know about us very good, because we have one of the biggest conference about AI and big data, about web technologies and so on. And we organize webinars, and they give new customers for us and new users. And publications work good too. So this several steps what help us to growing. Today our team is 8 guys, and 2 guys live in Germany, and other team are from Ukraine. This several hour conference. Thank you.
Very good. One of the big challenges we had with our project is it could do 1,000 different things, and trying to sort of narrow it down to what pieces do we really want to get out first? How do we target that low-hanging fruit and get into market so that customers could utilize this system to do something very useful for them and have them adopt it, and not only for them but for their industry. Because we really didn't want to build, so we're an infrastructure kind of thing, so we didn't want to build all the user apps. We wanted to have somebody else build the medical system on top of this, or the database, or other things. But in order to get your infrastructure sort of recognized out there, you have to build a couple of things so that people will say, wow, that works in this instance, and we're going to try it in a different area. And so we wasted a fair amount, not really wasted, but we'd go down different paths. We'd say, oh, the first thing would be some kind of photo app that helps you organize your photos or your music or something like that. So we built some kind of consumer level thing. So we started working on those features that made that really possible. It wasn't wasted work at all, but when we switched and went a different direction, those features were part of our first product. And so, but we sort of circled back, got some of the database stuff working much better, and that's frankly where our first product is coming out, is these very flexible relational tables that the mortgage industry right now really needed. So that's kind of where we are. But my biggest plus on that side is when I hooked it all up and it like worked the first time and was giving me very favorable results. That was just very satisfying to try something out completely different and have it work the first time. So.
Excellent.
Well, in my case, I think it is very related to my background as a researcher. Indeed, as a researcher, we have been conducting research in one of the most difficult areas of HPC, that is, how do we make parallel programming easier? And there has been a lot of very brilliant researchers for more than 20 years that have tried to address that problem, and they have all failed.
Yes.
Indeed, there is no product nowadays that can even provide a solution that is usable in real codes. So from a research point of view, I know and my team knows that we can do it. The question is, how do you demonstrate that? How do you show that? And in the end, what you have is a technology that is able to succeed, and we are beginning to demonstrate it, where the others have failed for more than 20 years. And you have a technology, you don't have a product. So one of my personal bets was, we will try to build the product that I really think people is dreaming about. That is, what at some time was called a parallelizing compiler. So we tried to build it, but we faced the real world when people said that they do not believe that that kind of tool may really exist and can really be built. So we failed. After more than 3 years trying to build that product, we failed launching it, and we faced a very high wall of the market saying this is not possible, and they really didn't give us 1 minute of their time to try to test it.
Don't waste my time, it's not going to work.
No time.
No.
So that was the worst thing.
Yes.
Realizing that you think that this product will be able to engage people, and realizing that the market doesn't believe in what you are really trying to say. So related to that is how now we have a very powerful and versatile technology. How do we figure out to come out with a product much more simple than the first one? You can imagine in a ratio of 1 to 20. So even simpler for us to build. Even simpler, we can build it in less time. But this is really what people is really wanting to buy. So we came up to that after engaging with the Oak Ridge National Laboratory, with and the contact with them and their users, and knowing really what they are really willing to have, and trying to find what is the first very simple minimum value product that we can build so they can really test it. And that's the moment where we are now. And that is the worst part. And the best part is that all this
zigzag.
This zigzag, we finally have achieved this first industrial recognition by being selected for this emerging technology program with this first product that is much more simple than the one we really failed to launch at the market 1 year, 2 years and a half, 2 years ago. So that is, I think, the best and the worst during this 5 years journey.
Wow, very good. Dmitry, how about you? What was the hardest for you?
It's Fly Elephant. It's my not first company, and we between the launch of this company, I prepare many, but when we launch it and we launch the system, will be very hard. Was very hard to support the users to very quick change something in our system, and then will be very hard to understand where the money and how to do it, how to take it, and now we change all what we do last year about do money, and now we start new etap of build the business model, understand how work with companies and what we need to do to sell it. It's I think hardest work.
Is there any question from the audience?
I guess specifically to Manuel, since you said it specifically, but also the question to the rest of the panel, you said that starting up is very different from being a researcher, and you said you spent many years doing research prior to that. So since it's so different, do you think you could have done what you're doing now without 10 years of having spent in academia?
Good question. Good question.
I will ask too, because I'm a researcher too. For me, I think it's why it's hard to start the startup researchers and need many time to understand how it works, because in research we have money from some grants, and we don't need to think about how we create new money and how we grow the company. And when we start the growing, create the company, we need all know about all these questions. So many we need to learn.
Okay, I have this one. So from my point of view, I can share my personal experience. Being a researcher is I've been lucky to find conducting my research something that nobody else was doing at that time. That was really hard from a research point of view, because I was attending very top conferences around the world. I could hardly find someone to discuss ideas, so that my publishing my results and finishing my PhD took me much longer than expected if I could have discussed in these top conferences. So from the point of view of research, that was hard, but from the point of view of starting up, it was a very big opportunity, because I realized that everybody else was doing it in some way. We could do it in a very different way. So this is naturally a very big opportunity for innovation and creating innovative tools that you really can commercialize. And researchers, as researchers, we are people that we have all of the time to find the perfect solution to a problem. When you go down to the market, you are talking with professionals that are not researchers, and they have time constraints. They're not looking for the best solution. They're not looking for the peak performance running their parallel codes on a supercomputer. They just want to run them fast and the time constraints that they have. So they gives you to build products that they don't really need to be the best ones, but they have to be innovative and solve problems on a daily basis in the work of these professionals. You don't need to build the best tool, based on the best R&D results. You just need to build something different that you can commercialize and that solves problems on a daily basis to people that is using, in our case, parallel programming to run parallel simulations on supercomputers. So I think that's a really different mindsets, mainly opposites at some point.
Well, I was never in academia, so other than a student, but I've been part of startups before. This is my first startup, so it's been a challenge because I'm a techie guy. I haven't had to wear the hats of the salesman and the manager and all those other hats before, and so this is a challenge for me. But
Very good. We're going to have to wrap. Go for it. Go for it.
I was just going to ask a question of just being in this industry a long time. The venture community does not love HPC. Right. They think it's niche and they think it's hard to scale, and they think that the pace of innovation is, like where do you jump in? So I'm curious, how do you build your story to investors so they don't feel like they're getting kind of locked into a nub of a market that's not relevant in terms of, we talked about the return on investment. So I'd be just curious on how you're attacking that problem.
Manuel, you want to take that first?
Okay, we come from Spain, and I think Spain is a quite different ecosystem from the industrial and investor point of view than the US. But the question that you have raised is exactly the same. We talk to them about HPC supercomputing, and they say, what's that? What is it that useful for? So really convincing them that it is really something that is attractive now. It has been attractive for 10 and 15 years and will be even more attractive as it gains more vertical markets, as you predict in your market trends in the following 5 to 10 years. It's really hard to do it. But at the same point, HPC has something that is really good from investor point of view. It's a market niche, but it is what they call it very concentrated. I mean, you attend supercomputing and you can have access to the whole community. That's something they really like because you spend much less money in pre-sales and marketing because you have all the community concentrated in one place during 5 years, during the 5 days or the whole year, during the year. Other markets are not like that. They are more spread. So they are fearful of these spread markets. So if you can begin with a niche market that is highly concentrated, and HPC, we first believed that it was a market niche, but they really thought it was really small. It is small for very big investors, for a Series A, B, or C. But for pre-seed and seed investors, it's really a big market because when you say we are talking about $6,000 million each year, and you can achieve, 0.01% of that in your first sales, it's really a big market for the beginning. So you can say that it is niche, but it is concentrated, and it is a market that is very is willing to find new innovative solutions because it is really complex what the people is doing in this world. So it is so complex that they need all the help and all the need that you can have, that you can provide them. So that from our point of view, there were very good arguments to convince our investors to put money in our company. So I think that's something that we can defend and from the point of view of the HPC market. Presidency.
And you can go next.
Well, yeah, in my case, my investment has come from people who have seen this as strategic for their market. I haven't had to go out and try to sell this so far to the venture capitalists or just I want a 10% return in 6 months kind of thing. And so yeah, they're the people that understood what this meant for their market. They understand how. I mean, they don't understand the technology all that well, other than I know it works for my uses, and I know I've got 100 competitors that are having the same problem as I am. So if we can put some money toward this, it has a great potential in that market. So that's been my experience.
For now, we don't raise money from VC, but we start do it And when we speak with VC, we first of all select the VC with which we will speak, and very good understand what they have the focus. And we don't speak only about HPC, we speak about connection, HPC, and for example data science. And first focus we do for data science, and second it's HPC and how HPC can help data science.
You in the context of entrepreneurship. Now, Wolfgang, of course, you have a 50-year history of entrepreneurship since you were like...
If not more.
If not more, exactly. So maybe you can do a little bit and then we're ranking.
Yeah, so thank you very much, Shahin. So for me, having been in research and then in education, working with senior researchers on that side, working with students on the other side, and then becoming a consultant in the days of new computer architectures like vector and parallel computing, it was almost natural that you contact industry, you want to work with them. So I had early contracts with IBM and digital equipment, which we heard previously. So, and I got overwhelmed, too much work, very natural. You look for more people, and then you say, okay, let's found a company. So all this phase was very evolutionary, mainly based on your nature, your character. I was an engineer by genes. My father was an engineer, and we did things together in the very early days. So I was very open-minded, I would say. Jack on all trades, I think you say.
Jack of all trades.
Of all trades, yeah, as you say here. Very outspoken. So after 1 year, we got venture capital from Atlas Venture already, and it was HPC then, so they weren't shy to try it, kind of. And after that, there were so many opportunities that we founded one company after the other. So there was, in the 90s, we founded 7 companies. One failed, which was good. So it was hard to learn about that one. A few others I give back to the people who worked there, because this was a requirement of Sun Microsystems to get into Sun clean, right? So there was Genius Internet, Genius Parallel Computing, Genius Graphics, and then finally Sun Microsystems acquired the grid engine part of that company, and we shut down the others. The others are still alive. So I would say that was an easy one. And later on, Bora contacted me with a great idea, which turned out to be a little bit modified, but then, and I think the rest now we talk later. So that, yeah.
All right, how about you, Bora?
I think Wolfgang is accurate on that. It's there's something wrong with the genes of startup founders. This is it just is in you, and you can't help it, and you have to go do it. It's like a calling. In my previous company, where I worked for 10 years, I started 3 divisions and managed 4. So that's no different from being an entrepreneur inside of a big company either. So. It just is in you.
So both of you really attribute that spark for entrepreneurship to just kind of your character.
It's a genetic defect.
So you consider it
and the follow-up education towards that, which basically accelerates that, strengthens it.
So that's really my next question. Now that you've done it a few times, in your case many more times, and now you've learned everything. If you knew then what you know now, would you still think that wouldn't it be easier? How much easier would it be now that you know it all? Would you just
I'll take it first. If you know what it takes up front, you probably wouldn't do it. In some senses, it's probably like having a child. If you knew what it would take, you'd probably say, I'll never have a child. So, by the way, interestingly, the analogy applies to startup companies, because knowing what you will go through, you have a usually you have a second child, and that doesn't make any sense either. So I think it's just in you. You feel like you have to do it, and that's where it comes from.
Yes.
All right.
Nothing to add.
So before the very first one that you did, do you remember what you were feeling? Was it, just an exhilarating? Were you scared? Were you, but something kind of, what was that feeling like? Go ahead.
So I was not scared in the beginning because, as I said, it was usually a natural evolution. So ideally, what happened so almost in our situation and before was personally I was not looking for opportunities to do something great or so, but it was really vice versa when thinking about it. The opportunities were looking for me, so they were there. And being a curious character, you jump on them. And you don't really care if, thinking about business and community and whatever. You do it in the beginning, certainly, just for yourself.
One thread that really comes along with everybody that has spoken is just the idea of taking action. Mm-hmm. That they've just taken action. They've done something. Oftentimes not knowing where it might end, but you just get started and you jump and see what happens. Yeah. I think that's like a thread, isn't it, here? Now let's change. So our theme for this event was basically disruptions and opportunities, right? And Uber Cloud is, obviously in, the Uber of the cloud, basically, right? So tell us kind of how you saw cloud computing coming, how you saw it impact HPC. There were a lot of people who thought cloud computing and HPC don't mix, that there's no excess capacity, everybody's on 10%. Just tell us why you thought that was a great idea.
So he saw it coming.
So it's his fault. Okay.
He stopped.
So Wolfgang had a conference called HPC in the cloud. So he saw it coming too. He's not being truthful. In my case, I'm not an HPC. I'm not necessarily from HPC myself. I came from cloud computing background. I ran data centers for banks and other institutions. What I realized in technology is, sorry about that. What we realize in technology is technology does not percolate in one shot. It's more as it grows in waves, so to speak. So you can actually, you may not necessarily be able to predict when the wave will eventually arrive, but you can predict that there will be waves of growth. So for example, it is quite predictable that a mega trend like cloud is going to have an effect on another large industry or like HPC, for example. You can predict that it is coming. And if you can give yourself a few years of head start, knowing that this wave is going to hit shore, and take part in that swell, then you get a good chance to benefit from it. So mine was a very deliberate search of trying to figure out what other field is lagging behind in cloud computing, and HPC was the market that I picked, and hence approached Wolfgang through that.
Okay. So we heard from you guys, of course, in SC14. It's 2 years later. Catch us up. What's happened in the past 2 years? What all cool stuff happened, and what is your outlook going forward?
Yeah, so to look at 2014 first, and then do the big step 2016.
Yeah, at this point you can.
Which is, yeah. Do you understand me like that?
Yeah.
Oh, okay, good. Thank you. So when we started, so when I got this email from someone I didn't know, so his name was Bora Genir, and asked me the question, so why an HPC, not yet cloud? So we got together and figured out that we didn't really know. So if there is a need, if engineers, scientists are really interested into that, etc. So in the first 2 years, basically, we said we need to learn more. So it was really just about learning about the benefits and the challenges firsthand. So not from some articles or so. So we created these UberCloud HPC experiments. And in the meantime, we have done 194 and written over 80 case studies, and we published everything. So the idea was really, in the early days, to do this research, then create a community around it over all these 16 verticals, which we hoped at one point in time speak cloud. So at this one common language. We excited Intel because the idea was really to democratize HPC because of this easy economic access to HPC resources in the cloud. So Intel helped us basically to do all these experiments and to finance them. And the other part came out of our pocket. So that was the first 2 years. We explored everything, including potential technologies which could solve the challenges. So that was more on Burak's plate then. So that was 2014. In 2014, we thought, now we know almost everything about it, right? So we started developing a business around it, and we were clear. We needed an online marketplace, a shopping mall for engineers, so to make it really easy, like Amazon, when you buy books, etc. Now engineers can buy one-day answers on 64 cores for $299. Right, so it was really identical to that one, which we did since then. So now we got to 2016. So last year, about the same time, we had the technology completed. So beyond proof of concept, and we decided to go to market, and that was early this year. And so early this year, and we survived through friends and family support in the last 2 years, plus continuous support from Intel, plus also then from HPE, and partially from Azure, from the Azure team in Microsoft. We were all about not cloud, but we were really all about HPC as a service to democratize HPC and take it to a much broader market, which we now see in our early customers. They are coming from everywhere. And interesting enough, what we see, we thought, okay, small, medium enterprises, that's a great focus because they don't have everything. This is the have-nots.
It's always been a gap.
It's huge gap. And now they are coming with trials, with first small projects getting larger, but also the big guys, they are coming. They have peaks which they cannot basically support in-house anymore, and so they test that. Yeah, exactly. Excellent. So that's where we are. Technology.
That was a very good coverage. In the midst of it all, we started developing the Uber Cloud technology stack. So for us, the market and the problem was the first. The technology came much after, so we had the luxury of looking at what is really needed and building that. We didn't want to build something without understanding what was necessary. So now, with a very purpose-built technology solution, we find great success in our focused market.
I'm going to ask the audience if anybody has a question there. But in the meantime, I'll ask you what I've asked everybody else. What lessons have you learned that you can share with someone who's thinking about doing this?
Yeah. So it's always most important to find out if there is a pain somewhere. And I mean, it is almost easy when you work in a certain area like HPC for 30 years or so, right? I mean, you felt the pain every day, right? When accessing a supercomputer or a high-performance system, etc. So there was pain out there because the engineers, 20 million or so, most of them have just their workstation. They have just 4 to 8, when we started, 4 to 8 cores on their desks. And 57% always complained about the limitations of a workstation, according to the Council of Competitiveness research paper. So that was the pain factor. And then we started to look at the solutions, which we had in mind, but we didn't, in the early days we couldn't really prove, which we did. So there has to be a need, and there has to be a 10x improvement somewhere, which we tried to find. So that is the most important thing, I think, in my view. And then it's almost natural when you have found that one and you have found that one and combined it, that when you get out, the people say, aha, that's what I need. And so.
Dr. La?
So I wanted to ask, like, when you talk about your entrepreneurship is in your DNA, you know, it's that when you were growing up, when you look back now, do you see milestones where you recognize or something happened that, you know, helped develop that kind of entrepreneurial spirit, if you like, or that risk-taking or that desire to start something, or that was something that developed later on in life? What's you?
Yeah, as human beings, we have this tendency to look back and make inferences. In this specific case, I don't believe it happens like that necessarily, but when I look back now, I like to think, for example, my father is an entrepreneur, so that's probably a reason. I studied, you know, in business school, so that's probably a reason. I started working in Silicon Valley. I mean, there's something in the water in Silicon Valley, probably. They mix it in there. So yeah, I mean, I can see these as potential reasons, but I think it's very difficult to find one point that says, oh, it happened because of that.
Because, you know, sort of, I guess the thing I'm also trying to understand is, you know, beyond Silicon Valley or whatnot, you know, if we recognize that innovation and technology drive society forward in the general sense, how do we make this sort of more, you know, overarching so more people get involved, you know, in being an entrepreneur, in doing something different? I think, you know, you see reports that, you know, there are more kids now that start, you know, companies and start things that stay in companies. You know, that seems to be a trend in the labor market now. So, you know, how do we expand on that or encourage it or kill it or whatever?
Yeah, so a good point. I'm not really a believer in the DNA thing. So when we look back, it is really about education. So it's your parents and your environment, how you grow up. And when I was a professor, I didn't really like just lecturing. The most pleasure I found in handing over projects, and I think this is the key. So to learn people how to start something, to take it through, to succeed, to summarize it, to present it. So basically that's a startup, going through major phases then. And that's how we can teach young kids how to successively get into an entrepreneurial spirit and finally end up, if we are lucky, at entrepreneurs.
Very good. Any other questions from the audience? Manuel, you have one? We can speak later. All right.
I have a follow-up answer to a previous question.
Go
I
for
think
it.
it came from Deborah.
Deborah, you were asking how come the VC community or investors in general see HPC as a area where it's not very interesting. I think that's a problem of semantics more than anything else. HPC is a solution. Whenever you talk to people about a solution and not necessarily a problem, this is not unique to investors. You'll get a blank stare from a customer too. I think this is the most important thing when you're trying to communicate with human beings. Just talk to them and sell them the problem first. And then talking about a solution becomes a lot easier. I think even we have made this mistake of going in and saying we talk about HPC in the cloud and it's a blank stare. But when you tell people that, hey, this is about making better products faster, cheaper, they go, oh, wait, I can't relate to that.